Hi guys, let's take a look at the steamboat problem. It says Mark Twain sat on the deck of a river steamboat. As the steamboat's paddle wheel turned, a point on the paddle blade moved in such a way that its distance d from the water's surface was a sinusoidal function of time. So I put a little green ribbon on my paddle wheel, and he watched this little ribbon come out of the water, and the paddle wheel moves counterclockwise, by the way. Um, when his stopwatch read 4 seconds, the point was at its highest 16 feet above the water surface. So you know one of the points that we need to get is the high point, and then the low point, and then the high point again. High, low, high. That's our goal. So when the stopwatch read 4 seconds, the steamboat the paddle wheel was at its highest 16 feet above the surface. Okay, the wheel's diameter is 18 feet. The diameter is 18 feet total. So the complete revolution every 10 seconds. So every 10 seconds, it makes one complete revolution. So if after 4 seconds, we are at our high point, in 16 more seconds, we will be at the high point again. Sorry, every 10 seconds. So in 10 seconds, we will be at the high point again. So that would be 14, 16 would be the second time we hit that high point. 14 seconds, and we're 16 feet high. So um, if the wheel completes a revolution every 10 seconds, then it completes a half revolution in 5 seconds. So it took 4 seconds to get to the top, 4 seconds to get to the top, 5 more seconds to get down here to the bottom. So that's a total of 9 seconds. And we are, let's see, what is our distance from the water's surface? Well, the paddle wheel has a diameter of 18 feet. We're 16 feet above, so that makes -2 feet. That makes 2 feet below, so the actual coordinate is -2, 2 feet below the water surface. Okay, so we have our high, low, high. We can answer these questions over here at the side in 1A. I'm going to start with the period. The period is 10 seconds. The frequency is 1 over the period, so that is 1/10. The maximum distance above the water surface is 16. The time at the highest point is 4 seconds. The maximum distance below the water surface is 2 feet. The paddle wheel's diameter is 18 feet and the radius is 9 feet. Okay, letter B says express the paddle wheel's highest point as a coordinate t, d. Use the highest point, and the highest point's distance above is d. Okay, so that would be 416. That's the first high point. Letter C, how many seconds must pass to reach the high point again? 10 seconds must pass to reach the high point again. So the second coordinate is 1416. Determine the coordinate of the low point. We've done that already, 9, -2. Okay, use a graph to sketch. All right, to save a little time, I went ahead and graphed the 3 points. I plotted the 3 points, 416, 9, -2, and 1416, connected them. And now I need to find my midline. That's the first thing I always want to do. I average my two y values. -16 plus -2 is 14, divided by 2 is 7. So right in here, I should have a midline. That looks just about right for doing it freehand. And you can tell it's 7 plus 9 is 16, and negative 2 plus 9 is 7. So my amplitude is 9. The next thing I want to do is draw my, whoops, that's not erasing. The next thing I want to do is write the equation. So I have y equals my amplitude we just talked about, 9, cosine, my b value, b. To find b, we take 2 pi divided by the period. You can see from 4 to 14, that is a distance of 10. The period is 10, and we discussed that earlier anyway. So pi over 5 reduced. So b equals pi over 5. Now we look for our phase shift, and we did have to shift. Our graph shifted 4 to the right because normally cosine starts on the y-axis, but it doesn't in this problem. It starts 4 to the left. That point has been shifted 4 to the right, 4 to the right, and that's why we write x minus 4 and close the parenthesis, and our vertical shift is up 7, and there we have our equation. From that equation, we can, let's see, where is the center of the paddle wheel, or the midline? It's wanting to know the midline. The midline is y equals 7. I feel confident that you can plug in 5 seconds for t. So I normally change my x's to t's, and I change my y's to d for distance. All right, solve the equation for time. I think I'm going to stop after this one. So the first thing I would do is subtract 7. D minus 7 equals 9 cosine pi over 5 times the quantity t minus 4. Divide both sides by 9. So d minus 7 divided by 9 equals cosine pi over 5 times the quantity t minus 4. Now I need to get rid of cosine. To get rid of cosine, we take the inverse of cosine. So that cancels out cosine. What we do to one side, of course, we do to the opposite side. So on the left side, we have inverse cosine, d minus 7 over 9 equals pi over 5 times t minus 4. The next thing we would do is multiply both sides by 5 over pi, multiply by 5 over pi. So now we have 5 over pi, inverse cosine, d minus 7 over 9 equals t minus 4. We would add 4, and that would give us t. Okay, I'm running out of room down here. All right, I hope that helped you guys. I'll see you in a couple days. Bye.